Hello everybody and welcome to the 26th video of the TypeScript Game Engine tutorial series. In the last video we actually went through the process of implementing our bitmap font, and we have our font glyphs which hold all the value for each one of our individual characters, and we have our bitmap font class stood up and ready to go. And so in this video I actually want to put these things to use. I want to write up the component that's going to be using this logic, and we'll write up some of the other various changes that need to happen, and get this actually into the level so that we could see it operating. So the next thing that we're going to want to do is create a BitmapFontManager. So we're going to say new TypeScript file, BitmapFontManager. And it's under namespace TSE, and we're going to export class called BitmapFontManager. Okay, and what we're going to do first off is keep a private static list of fonts, and that's going to be a dictionary. The key type is going to be called, it's going to be held by a key of string, which is basically going to be the name, and then the value is going to be the bitmap font itself, and we'll initialize that to an empty object. The next thing we'll do is we'll add a public static function, and we'll say add font. And we'll pass the name of the font, which is of type string, and we'll pass the font file name, which is also of type string, and it's return type void. And so in case you haven't guessed, this is going to be a completely static class. We don't need to create an instance of it. We could just use it statically. That way we can call it from anywhere in code. We don't have to stand it up. We can just simply call these methods and move on. So we need to say BitmapFontManager underscore fonts, and we're going to say the key of name is equal to a new bitmap font, and it's going to take in name and font file name, which I don't actually have. If you recall, the bitmap font doesn't actually take these properties in. So that means I need to go back to the constructor here, which looks like I was just using a default constructor, so we need to add a constructor, which takes in name and font file, say string. Okay, and from that we'll just say this.name equals name, this.font file name equals font file. Okay. Back in the Bitmap Font Manager, that is actually all we have to do for adding a font, but we need to be able to get it. So call this get font. Again, another static, and we're just going to get it by name. Turn type bitmap font. And what we want to do is we want to say if bitmap font manager dot underscore fonts key name is equal to undefined, we're going to throw a new error. And we'll say a font named name does not exist. Okay? Otherwise, we're just going to return bitmap font manager dot fonts name. That's it. That's all there is to getting a font. So the next thing is we need to add just a couple of hooks in here for the engine to interact with it. So we're going to have a public static load, which is return type void. And we're going to get the keys, which is basically we're going to get all the we're going to get all the keys for the dictionary. So okay, and then we're going to loop through them. Key of keys, right? And then we're going to say BitmapFontManager fonts, and we're going to say key. We're going to call the load method on it. That's all there is to the load. We're just basically going to say any fonts that have been registered, load them up. Final method is going to be another static method, and it's going to be called update ready. Return type void. Actually, return type boolean, sorry. Okay, and again, we're going to get the keys and iterate. So I'm actually just going to copy this code, and I'm going to say if not bitmap font manager fonts key, and then is loaded. Right. So if it's loading, we're going to go ahead and put a debug message out to tell us it's still loading. So font key is still loading. Right. And then we're going to return true. Sorry, false. So basically we're going to say it's not update ready yet. We still have a font that's loading. Hold off for now. If we reach the end of that loop, we're going to say console.debug all fonts are loaded. Return true. And that's it. Bitmap Font Manager is really, really simple. But this gives us a way to not have to worry about how the fonts are loaded or any of that, or how to retrieve them. It just gives us a nice, clean way to handle this. Okay, so the next thing that we're going to create is something called BitmapText. And BitmapText is actually it's going to be the graphics object that uses it uses a bitmap font. But this is the graphics object that actually is responsible for rendering to OpenGL and creating the buffers and holding the text value and all of that. And so this is ultimately what's going to be driving the rendering of the text under the hood. So we need a couple of private values. Before we do that, we need to export a class. And we're going to call this BitmapText. Right, and in here we need some private values. So we need a font name, which is type string. We need a dirty flag, so we'll say is dirty boolean, and we're actually going to start that off as being false. And then we need some protected properties, because we might want to extend this at some point. So first say name string protected. So we need origin, which is the vector3. We're going to say vector3.0. Okay. And then we're going to need a buffer. We're going to need a buffer, which is going to be a GL buffer. We're going to need material. We're going to need the bitmap font we're going to use. We need the vertices, which is basically just going to be an array of vertex, and we'll initialize that to an empty array. And finally, we need the text, which is a string. This is the actual text we want to draw out. Okay, so need a public constructor. And this is going to take in name and a font name. Okay, so we'll say this dot name equals name, and then this dot font name equals font name. That's it for the constructor. Let's set a couple of getters and setters here, just to make things a little bit more convenient. So we'll say public get name string, turn this name. And I'm actually just going to make a copy of this and say the same thing for text. And then we're going to say public set text value type string. Okay. And we're going to do a conditional check here that if this.text is not equal to value, then we'll go ahead and update it. And the reasons for this will become apparent in a little bit. But for now, let's just say this.text equals value. Make sure to use the underscores within this. And then we'll also say this.isDirty equals true, because we updated the text. Okay. Next, we'll have a public get origin, so vector3, turn this.origin, and we'll have a setter for that too. Set origin value vector3, and we'll say this dot origin underscore origin equals value, and we'll say this dot calculate vertices, which we don't have yet, but we will be creating here momentarily. Next thing before we forget, we need a destroy method. Okay, so we'll say this.buffer.destroy and this.material.destroy and this.material equals undefined. Okay, and we're not using the material manager for this because this material is not a material that is ever going to be used outside the context of this bitmap text. So this particular material should not be shared, should not be available anywhere else. And so we're just going to create it privately and destroy it privately. Okay. So let's go ahead and stub out this private calculate vertices. I'm not going to fill it in right now, but I just want to get rid of the error there. The next one we need is a public load method, which returns type void. And this is where a bulk of our logic is actually going to be, or at least, well, I guess not really the bulk, but a decent portion of it. So we're going to say this dot bitmap font equals BitmapFontManager.get font, this dot font name. Okay. And then this dot material equals new material. And for this one, we're actually going to create a dynamic string for the material name. So we're going to say, we're going to use an interpolated string here and say uppercase bitmap font and then we're going to use $sign. We're going to say this.name. And then we're going to use another underscore, and we're also going to make it specific to the size. So we'll say this.bitmapfont.size. Okay. And then for the diffuse texture name, we'll just say this.bitmapfont.textureName. And then the tint, we probably ought to expose this, but for now I'm just going to say color.white. Okay. So the material is created here, destroyed here, so we shouldn't have any memory leaks due to this. Let's go ahead and create the buffer. New GL buffer. And we'll go ahead and set up the attributes for it. So let position attribute equals new attribute info. Okay. Position attribute dot location equals 0. Position attribute dot size is going to be equal to 3 because this is position, it's vector 3. And then we'll say this dot buffer dot add attribute location position attribute. Okay. And I'm actually just going to make a copy of this because we need one more. But the location is going to be 1 and the size is going to be 2. And as you may have guessed, this is going to be texture coordinates. So text coord attribute. Rename this. Rename it there. And now that's all done. So that is pretty much it for the load. Nothing too fancy. Next we need a update method. So public update. And that's going to take in time, which is a number, milliseconds. And it's going to return void. And basically what we're going to do here is we're going to say if this is dirty, we also want to check and this.bitmapFont is loaded. So in other words, if we've changed the text and our bitmap font is loaded, we want to go ahead and calculate vertices. And then flip off the dirty flag. Flip off, that doesn't sound right, but whatever. You guys know what I mean. Okay. Next is draw. So public draw. It's going to take in the shader. It's going to take in the model, which is a matrix 4x4, and it returns type void. Okay. And first thing we're going to do is get the model location. And that is equal to shader.get uniform location. And in this case, it's going to be u_model. And then we want to say gl.uniform for fv. And we're going to say model location, and then false. Wait a minute. Sorry, that should be uniform matrix. There we go. GL uniform matrix F4V. False for the transpose, and then we want the model.toFloat32 array. Okay, so we're just going to set that, and then I'm just going to do the same exact thing for color, pretty much the same thing anyways. This is going to be u_tint, and we're going to say color location. Okay, and instead of matrix for it's just going to be a uniform for FV. Color location, and then it's going to be this dot material, there we go, tint dot to float 32 array. Okay, and then we need to go ahead and bind the texture. Why is this bleating? Expected 2 arguments. Oh, transpose doesn't belong there. There we go. Okay. So we need to say if this dot material dot diffuse texture is not equal to undefined, then this dot material dot diffuse texture dot activate and bind on the 0 texture unit, and then we're going to get the diffuse location. So I'm actually just going to copy this line here. Oops. So diffuse location, and that's going to be u underscore diffuse, if I can spell it right. And then we're going to say gl dot uniform 1i for integer, diffuse location, and then we're going to set that to 0. Okay, so now our texture is bound. And in here we'll need to say this dot buffer dot bind, and then this dot buffer draw. That's all there is to the draw. Alright, so now where the real meat and potatoes are is in this calculate vertices method, because this is actually what's going to take our text and create all of our individual little sprites for us and load everything into the buffer and get it ready to be drawn. So we need to start off by saying this.vertices dot length equals 0. So we need to reset the vertices, and we want to clear the buffer. Okay. And then we're going to keep some x and y trackers. So x equals 0, let y equals 0. Alright. And then, of course, similar to how we did before, we're going to loop through the characters of this .text. Alright. And if the character equals a new line, what we're going to do is reset x, and then we're going to add to y the bitmap font size, and then we're going to say continue. We don't want to do anything else. Move on to the next character. Alright. Otherwise, all the rest of this logic is to handle every other character besides new lines. So we'll say let g equals this.bitmapfont.getGlyph, pass in C. Okay. And now we've got, we'll say let min x equals x plus g.x offset, and then let min y equals y plus g.y offset. And then we're going to do something very similar. So max x equals min x plus g.width. Let max y equal min y plus g.height. G.height. There we go. Okay. And so these are going to be our vertex points. And so the next thing we need is our UVs. Right, so let min u equals g.x divided by this.bitmapfont.imagewidth. Okay, and what we're doing is we're basically saying we're taking this pixel space of this image and we're converting that to a UV texture coordinate of 0 to 1. So we're saying if it's 0, it's going to be over here. If it's 512, it's going to be over here. So 0 to 1. Okay, and the min v g.y divided by this dot bitmap font dot image height. Okay, and then of course we also need the maxes. So let max u equals g.x plus g.width, and then that's going to be divided by this dot bitmap font dot image width, and then the max v is going to be equal to g.x I don't know why I keep typing gl, g.y rather, plus g.height divided by this dot bitmap font dot image height. Okay, so now we have our points for our vertices, and we have our texture coordinates. So the next thing we need to do is we need to say this dot vertices dot push, and we want to say new vertex, and in this we need to pass x, y, z, texture u, and texture v. So we're going to use combinations of the min max positions and min max UVs to actually build this out. So first one we're going to say min x and min y, and then for the z-axis all the way down we're going to be passing 0, and we're going to pass min u and min v. Nice and simple for the first one. I'm just going to copy this line of code, and so the next one is actually going to be min x and max y, and then min u and max v. Okay, so the third one is going to be max x and max y, and max u and max v. And then we're actually going to wind up with a duplicate of the same exact thing, because our next point, or our next triangle of this particular quad is going to start at that same point. Okay, so I'm just going to paste that again twice, and then on the last line I'm going to say it's going to be max x. Okay, so that one can stay, and then wait a minute, I might have messed this up here. This should be max x and max y. And then this should be min. Wait. You know what? I'm just going to do it this way. So it should be min x, max x, and then max x 2 more times, and then min x. And then for this one, it's going to be min y, max y, twice, 1 more time, min y, and then min y. Okay, this is going to be min u, max u, min u. And then this last column is going to be min v, max v, and then max v 1 more time, and then min v. I think I've got that right. We'll know when we run it. Okay. And then we're going to advance x by the g.x advance. So we're going to just add that on. Okay, so this is actually what's going to create all of these little individual boxes for us. And so once all that's done, we need to actually feed that data into our buffer. So we want to say for let v of this dot vertices, and say this dot buffer push back data v dot to array to array. Okay, and then we could say this dot buffer dot upload, and then this dot buffer dot unbind. Okay, I think that looks pretty good. I think we should be okay as far as that goes. So that is pretty much everything I think we need to do in the BitmapText object. Okay, I know this is a lot, but and I promise we're getting there. We're almost there. We're going to be able to see this running very, very soon. So just bear with me a little bit longer, and we'll get there. So the next thing I need to fix is actually a bug that I found in the actual texture file itself. So in the constructor right now, we're always doing a subscription for the message load, or for the asset load rather. And we don't actually want to be doing this here. This really should be moved to here. So if the asset is undefined, then we listen for the message. Otherwise, we don't. And this is actually going to fix some of the bugs that we've had with loading the game when it's cached, because we could just straight away load the texture from the asset right away if it's already cached, it's already loaded, versus having to listen for the message and potentially not get it. One more thing that I want to fix before we move any further is there's a couple things that I noticed in the engine class that also need to be changed. First of all, right before we register our material, we actually need to load our fonts. So let's go ahead and do that while we're in here. And we're going to say BitmapFontManager .add font, and we're going to call it default, and it's going to be in assets fonts text.txt. Okay, and then we're going to call BitmapFontManager.load. So that's all in there and hooked up now. So the next thing that we need to fix is some of this preloading stuff, and when this actual change zone gets called. So I'm actually just going to remove this line from here for the time being, and we're still going to leave the resize in there, but we're going to kill this loop call too. And I'm going to put a comment in here. We need to begin the preloading phase, which waits for various things to be loaded before starting the game. Okay, so this call this preloading, and we need to create that, but we'll come back to that. All right, the next thing is in the loop. We actually are going to move our request animation frame to the loop. So I'm just going to actually move this up to the end of the loop, and that's all that really needs to change there. But now you'll notice that loop actually isn't being called, so we need to fix that. And this is where we're going to create our preloading. So private preloading. Okay, and this returns type void. So this is going to operate sort of in a game loop of its own, but in a different state. And this is probably something I'm going to wind up enhancing in the future, but for now, this will work. So the first thing we want to do is to make sure to always update the message bus. And here we're going to call message bus.update, and we're going to pass 0 because we don't have the game time here yet, and we don't really need it at this phase. But we do want to make sure that while we're preloading, we're continuously updating this message so that messages at least can be sent while we're waiting on some of the other stuff to load. And the primary reason for this is we want to say if BitmapFontManager is update ready, or if it's not update ready, then we want to say request animation frame, and we're going to say this.preloading.bind this. So this functions a lot like the loop, but instead it's its own preloading loop that specifically checks to make sure things are loaded. Now, the reason I'm doing this with BitmapFontManager is because bitmap fonts are sort of a system level thing, and at some point our game engine really isn't going to be able to run without these. So this stuff really has to be up and running and loaded in order for us to continue. So if we're not update ready, we're going to request the animation frame and boot out early. If we are ready, this is where we're actually going to load up our zone. And I'm going to put my to-do back here. Make this configurable. Okay, so zone manager, change zone 0. Okay, and now here is where we kick off the render loop. Right, so we just call this.loop. Okay, I think that's everything as far as the engine is concerned that has to change. So now we can actually go on to creating the component. And the component actually, because of all the work that we've done under the hood, the component is going to be really, really simple to put together. So we want to, under components, add a new TypeScript file. And we're going to call this BitmapText component. Namespace TSE, export class. So obviously, just like we've always done with all the other components, we need a data class, BitmapText. Can't type tonight. Component data implements iComponent data. Okay. So for this we need a name, type string. We need font name, also type string. We need an origin, which is going to be a vector3, and we're going to default that to vector3.0. And then finally we need text, which is a string. Whoops, lowercase string. Okay. And we need a public set from JSON. Set from JSON. And of course that's going to take JSON of type any. Return type void. And in this, we're going to say if JSON.name is not equal to undefined, this.name equals string JSON.name. Okay. I'm actually just going to reuse this code for the next few things. So font name, and then text. Thankfully those are all the same. And then origin, which is going to be a little bit different. So we can actually say origin dot set from JSON and JSON.origin. And that really should be it for the data class. Next, we need the component builder, so we'll export class. I'm just going to copy this and call it builder implements I component builder. Okay, and public get type returns type string, which returns BitmapText. Right, and of course we need a public build from JSON, and that's going to take the JSON type any, and it's going to return an I component. Okay, so we'll say let data equals new bitmap text component data dot set from JSON, and then we'll say JSON, just pass that through, and then return new bitmap text component and pass the data to it. Whoops. Obviously we don't have the bitmap text component, so that's the next thing we need to create. And we're going to say extends base component. And this one is pretty straightforward too. It just has a couple of private properties. So we have bitmap text, which is a type bitmap text, and then font name, which is a string, and that's really it. Just to create a public constructor, and this is going to take in the data, which is the bitmap text component data, and we're going to call super and pass through data, and then this dot font name equals data dot font name. This dot bitmap text equals new bitmap text, and that is going to be created based off of this dot name. This dot name, and then this dot font name, and we'll just say if data.origin dot equals vector3.0. So in other words, if it's not equal to vector3.0, then we're going to say that this dot bitmapText.origin dot copy from data.origin. So we only bother with the copy operation if it's actually been set to something. Otherwise, it's already defaulted to vector3.0, so we don't need to do that operation. And then we'll say this dot bitmapText.text dot text equals data.text. Okay. So just a couple of more things to toss in here, just to hook in. So we need a public load, return type void, this dot bitmapText dot load. That's all that calls. We need a public update, which is, it takes in time, which is a number, return type void, and then we can say this.bitmapText.update and pass through time. And finally our render, which is public render return type void, and it's going to be this.bitmapText.draw, and we want to pass the shader, and then the say this.owner.worldMatrix, and then call super.render and pass through the shader, just so that all the any sub-objects that exist get drawn as well. And I forgot to actually put shader parameter there in render, so I'll go ahead and add that. And then of course down here, similar to the others, we want to auto register the component builder, so component manager dot register builder, and we're going to pass new bitmap text component builder. And I believe that is actually all we need to do as far as the component. So as you can see, that's actually pretty straightforward. It's not really a lot of code. Not a whole lot to worry about wrapping your head around. The last thing that we're going to need to do to get all of this working is to actually add this to our test zone to make sure that we actually draw some text to the screen. Because if we create the component and we never actually configure the zone to load that component, obviously we're not going to be able to see anything. So, whoops, assets, zones. Let's just open up test zone. Okay, one thing that I noticed that I kind of wanted to tweak a little bit is when we run it, the duck is a little bit up too high. So I'm going to change the Y from 100 to 200. So the only thing that we actually have to do is we need to add a component, and I'm actually going to add the object definition, I believe, right after the duck. So go ahead and create the object definition. We're going to call this name test text object. Let's see. Let's set its transform. We want the position. Let's go with an X value of 130 and a Y value of, let's just say 30. So it's sort of towards the middle top of the screen. Okay, and then after the transform, we're going to put our components in there. And let's go ahead and just add our behaviors array while we're at it. I don't think we're actually going to need that right now, but at least it's there in case we need it. So in components, we're going to add an object. Its name is going to be test text. Its type is going to be BitmapText. The text for it, we're going to default it to just say, I don't know, I guess 0 for now. And the font name is going to be default. That really ought to be it. So let's go ahead and build this. And run. And I've got some breakpoints set in here. Let me just get rid of those. And I'm getting some errors, so let's actually just reload the cache here. Okay, so what has happened here? G is undefined. So what on earth caused that to be undefined? Let's take a look at getGlyph. So let's set a breakpoint at getGlyph and reload this real quick. Okay, so the character we passed is 0, so the character code at 0 should be 48, so it's getting that correctly. Are our glyphs... Oh, our glyphs are empty. Why would our glyphs be empty? Image file is not defined. Name is not defined. This is not defined. Data is not defined. What is going on here? Let's take a look at our BitmapFontManager fonts. So it looks like we have our bitmap font default is loaded. The texture name isn't set up though, which the glyphs and all that aren't set up. Oops, let's tse.asset manager, and we'll say loaded assets. Why is our fonts.text? Okay. Looks like our fonts text did not load. Why on earth not? So we have assets, fonts. Oh, because I'm searching for a text index, or an extension rather, and I have an FNT there. So let's rename that to text.text. Okay. So get rid of the breakpoint. Let's try loading this again. Now, why debugger is paused? PNG, there's no extension. Unable to load asset extension because there's no loader associated with it. So supported extensions are text. That doesn't seem right. It should be register loader. So we've got the loaders. The image asset loader ought to support PNG. It does. Oh, there's an extra quote in there. Bitmap font texture name. So wherever I'm setting the texture name, there's an extra quote in it. So the image file is getting set here. Oh, I know why. Because I'm doing the replace, and this replace is not actually being set to anything because this returns a string. It's not in place replace. So I have to say this image file equals this image file dot replace. Sorry about that. Let's rebuild and run. There we go. Okay. So we have our 0 that appears here. And just to sort of prove the point that this is dynamically updatable, I've actually got this string set up ahead of time just to be able to update this text. So basically what I'm doing here is I'm navigating the scene, and I'm saying basically the 7th child in the root, the first component, which is going to be this text, the bitmap text component. I want to set its text to 10. And you can see when I did that, it updated this value. So if we set it to something besides a number, I don't know, let's set it to Raffle. We can set it to Raffle. So there's lots of flexibility and lots of things that you can do with this system. You can load multiple bitmap fonts, and you can use this for debugging. You can use this for user interfaces, all kinds of things, and it's rendered directly to the canvas just like everything else. So let me go back and set that back to 0. So in this case, what we're going to do is we're actually going to use this to keep track of how many of these pipes that we've actually passed through without dying. And so that will be covered in a future video that is coming up soon. So with that, I'm going to go ahead and wrap up this video. Thank you guys so much for watching. If you haven't already, consider subscribing, and I will see you guys next time.